Today we're going to be talking about properties of triangles, and these are things like the angles and sides to where when there's something special going on, we can identify and name what it is. All right, before we jump in, we're going to review some things, and some of that is how we write and say what the triangle is. So as you see here, we have a triangle that's ABC. The way we would write it is as such. We would write it as triangle ABC using the little triangle symbol. So that's identifying which triangle it is. But we also have these things going on over here. And I just want to talk about what those mean. When you see this AB, what it's talking about is this segment here. And so what we're really talking about is the side from A to B. Now when you see this symbol right here, sometimes it has that arc in it, sometimes it just has that, but if you notice it looks a lot like a less than symbol, except for it has a flat bottom. A less than is more V-shaped where it comes down. It's talking about angle B, which is this angle right here. So when we're talking about angle B, we're looking at the angle where it starts, and it's the one that's projecting out this way, is the angle that way. So look at this next one. We have the angle ACB. Well, that can be confusing since it has all the angles. So let's look, let me get my highlighter. And when we do that, we start with the first letter, which is A. We go down to the next letter, which is C, and then we go to the next letter. So we're talking about that angle there, which can also be written as angle C. So when it has all three letters written, the middle one is always the vertex right here. So it's saying angle ACB is the same thing as writing C. It's like, you know, writing all your names as opposed to just your first name. So when we look at this angle over here, this XYZ, there are three different ways I can write the name of this angle. The first one is I can say that is the angle XYZ. I can also say it's the angle Y. That's my middle one. That's where my vertex is. And I can also say it's the angle ZYX. Notice that in all of them, Y is the center coordinate. So one last review before we get started. Most of y'all probably have already filled this out. An acute angle is less than 90 degrees. So it's something like that. A right angle is exactly 90 degrees. No more, no less. And it's often denoted with a little square. An obtuse angle is greater than 90, but less than 180 degrees. So an obtuse angle would be something like that. And we know 180 degrees is a straight line. So that is 180 degrees. And mine got cut off, but so I typed it up. It says the sum of angles inside of a triangle, if I were to take all three angles and add them up, they would equal 180 degrees. So it doesn't matter what type of triangle it is, all three angles will add up to be 180 degrees. And if you think about that a triangle is half of a rectangle or half of a parallelogram, what do you think the angles in a parallelogram or rectangle will add up to be? So no matter what, they will add up to be 180 degrees. All right, here's an important part you need to remember right here. Every triangle has at least two acute angles. One way you can classify a triangle is by using the third angle. Another way is to classify by using their sides. So first we're going to start with angles. And remember those angles, we can use that symbol. An acute triangle has all acute angles. That means that they're less than 90 degrees. A right triangle has one right angle, which we know that means is equal to 90 degrees. So right there is that angle. The other two will be acute. An obtuse triangle has one obtuse angle. So it means that angle is greater than 90 degrees. And then again, the other two will be acute. So you have to look at the third angle to classify by angles. Every triangle is going to have at least two acute. It's the third one that's going to tell you what to classify the triangle as. Now we're going to talk about sides. And before we get started, I want to talk about these little tick marks. These tick marks means that they are congruent, same size, same shape. So the hard part of these is remembering which name goes to which. With the scaling, the triangle has no congruent sides, which means that all sides are different lengths. So if this was 5, this was 7, this might be 9. So I'm just throwing random numbers in there, but no sides are the same length. And isosceles triangles have two congruent sides. And that's what that little tick mark means. That means that this side and this side have the same length, which also means that their angles have the same, the angles that create that side have the same measurement. So it would mean this angle, which creates that side, this angle, which creates that side, has the same measurements. And our friend, the equilateral triangle, has all congruent sides. All sides are the same. That means that if this is 6, this would be 6, and this would be 6. That single tick mark all around tells us that. So these are things we have to know so that when we start writing equations and doing this, we understand where everything's coming from and how our numbers are working. So now we're going to do some practice problems together. All right, when we classify each triangle by its angle and sides, what we really need to do with the angles is look for the largest angle. So that's a big hint. Let's write that down. Okay, so we have two classifications we have to do. So when we look at this one, we have 50, 50, and 80. All three of those are acute angles. So since all of them are, it is an acute triangle. When I look at the sides, I see that I have two tick marks. That means that this side and this side are the same or congruent. They're the same length. If you notice, the angles are also the same. So if I have a set of congruent sides, that means it's an isosceles. And I always think about it as I saw something I saw with two eyes. It has two sides that are the same length. So when we look over at this next one, I start with my angles. I have 70, 20, and 90. By the way, if you've noticed, if you add them all up, they will equal 180. But this is acute, so my larger angle right there is a right angle. So it is a right triangle. When I look at my side lengths, I have 15, 42, and 45. They're all different, so it is a scaling. I'm going to come down here to the bottom one. I'm going to start with my angles, 27, 38, 115. Well, that's an obtuse angle, so it is an obtuse triangle. When I look at my side lengths, they're all different, so it also is scaling. Now this one has a lot of information that's not directly stated, but it is here. So this angle is 20 degrees, and if you remember here, we said that the congruent sides, the angles will also be that create it will also be congruent. So what that means is, even though it's not giving me the two angle measurements, it's giving me enough information that I know that these two angles will be the exact same because they create congruent sides. And then I have this one's 20 degrees. And if you remember, we know that 180 is the sum of all interior angles. So the first thing I need to do is take 20 away from that, and I would have 160. When I have that 160, I have two angles that it needs to be split between. I'm going to divide by 2. Each of those angles is 80 degrees. And all of those angles are acute, so this is an acute triangle. Since it also has two sides that are congruent, it is an isosceles. So the important things are to remember is when you're classifying it, it will have more than one. It will have both this angle and its side when it gives you pieces of information for both. All right, so here it's going to ask us to write and solve an equation to determine the value of x in each figure. And this is the part we need to remember. The sum, that means if I add them all up, of the interior angles in a triangle is 180 degrees. So that piece of information is something I do have to know so that I can write that. Because I know that if I have 4x, which is this angle right here, I have 126 and 22. If I add them all together, I should get 180 degrees. So when I have this, the first thing I'm going to do is simplify. I have two numbers that I can add together. So when I do that, I simplify my equation to be 4x plus 148 equals 180. So now I need to get rid of this number. The opposite of add 148 or positive 148 would be to subtract, or a negative 148. So I need to remember, if I do it to one side, I need to do it to the other side because of this equality. That means that whatever I do here, to keep it balanced, I have to do it to this side. These two cross out, they create 0, and I get 4x. And when I take 148 from 180, I get 32. Now, I need to look here. My variable is still not isolated. I have a coefficient in front of it. This operation, there's no operation between my variable and my thing, so it tells me that I'm multiplying. So opposite of multiplying is to divide, and I need to do it to both sides. This tells me that x, when I simplify down, I've now isolated my variable. 32 divided by 4 will give me 8. So that means that if I plug 8 in to x, I would have my measurement of my angle. So here we have one that it gives us 48 degrees, it gives us 7x degrees, and it gives us this symbol. Hopefully you remember that that symbol means that that is 90 degrees. Again, when I add up all the angles of this interior angles of a triangle, it should equal 180 degrees. So that allows me to write my equation. So the first thing I'm going to do is I'm going to combine like terms, which both of these I can just combine and simplify. And I do that just to put like things together, just to make my life, I'd rather subtract 138 than to do 90 and 48 again each. So here I can do the opposite, which is the inverse. So instead of adding 138, I'm going to take away 138 from each side because I have an equality going on right here. So when I do that, these cancel out and I'm left with 7x is equal to 42. Now my variable is still not isolated. I have a coefficient with my variable that tells me it's multiplication. So now I need to do the opposite, the inverse operation, which is divide by 7. When I do that, I create that ginormous one. I've isolated my variable and I'm left with x. And 42 divided by 7 would give me 6. So that means if I put 6 in place of x, I would find out that that angle is equal to, what is 6 times x? What is 7 times 6 is 42.